Simply, it's a force that draws atoms toward each other. For example, you take two tennis balls and put them on the table. Some gravitational attraction already exists between them, but it's so imperceptible that you'd never notice it. However, if you place these tennis balls with two big chunks of metal and use very special equipment, you'll be able to measure the attraction between the pieces, even though it would be extremely small and therefore really hard to detect. But let's take the Earth. Our planet is a big number of atoms crammed together. That's why its gravitational pull is very real and very perceptible. In other words, gravity depends on the mass, which is in turn related to the matter. The more matter you have, the bigger the mass. And the bigger the mass is, the stronger an object's gravitational pull is.
The value of G on Earth. The value of G on Earth is 9.8 meter per second square. Life without gravity.
Dark side, what if we forgot about physics and imagined that one day our planet would give off a terrifying crack and gravity would just disappear? The most obvious outcome would be floating. I mean that you, the bed you've been sleeping on, your alarm clock, and your cup of unfinished tea would instantly rise into the air. At first, you might be surprised, and the whole situation might even seem funny. After all, if you were inside, you'd simply float gently upward until you bump into the ceiling. But your sense of wonder wouldn't last long. As you know, the Earth is spinning around its axis at a velocity of just over 1,000 miles per hour at the equator. That's why, if the gravity got switched off, anything unattached to the ground would simply fly off into space. People unlucky enough to be outside when the gravity disappears would be gone in the blink of an eye. Those people inside buildings would be safer, but not for long. It's true that man-made structures are supposed to be firmly rooted to the ground, and they would indeed stay put after the gravity vanishes. But sooner or later, they'd also give way. The same would happen with trees, however big and sturdy they may seem. Furthermore, the Earth would lose one of its best friends, the Moon. The only thing keeping the Moon from floating away and keeping our planet's natural satellite in orbit is the Earth's gravity. But even the loss of the Moon wouldn't affect you as badly as the loss of water and air. The atmosphere and all the water on Earth, including oceans, seas, lakes, and rivers, are kept in place by gravity. That's why, without this force, the atmosphere would eventually start to drift off into space. That means there'd eventually be no air to breathe. Well, this is looking bad. Water would begin to depart as well, along with its inhabitants. Imagine sharks, whales, and fish encased in bubbles of water and drifting off into space, and the bewildered expressions on their faces. The dolphins would be singing, "So long and thanks for all the fish." Later, when life on Earth would cease to exist completely, what with no air and water, the lack of gravity would finally take its toll on the planet itself. Without the main force holding things together, it would likely break into pieces and float off into space.
Effect on life on Earth without gravity. The air in atmosphere would immediately leap into the space, resulting in death of life. Second, the revolution and rotation of Earth and other planets would not happen, and same with Moon. Third, all the things building cars, human would fly in the sky and would collide with each other. Fourth, the tides due to the moon and sun would not occur. Gravity of other seven planets. First, Mercury. Mercury's surface gravity is 3.7 meter per second square, which is the equivalent of 38% of Earth's gravity. This means that if you weigh 100 kg on Earth, you would weigh 38 kg on Mercury. Venus. Venus gravity is almost 91% of Earth, which is 8.87 meter per second square. So if you weigh 100 pounds on Earth, you will weigh 91 pounds on Venus. Mars. The gravity on Mars about 3.711 meter per second square, which is much lower than it is here on Earth, 62% lower to be precise. At just 0.376 of the Earth's standard, a person who weighs 100 kg on Earth would weight only 38 kg on Mars. Jupiter. Jupiter is a massive planet, so it has a massive gravitational pull which is 24.79 meters per second square. Jupiter gravity is 2.4 times that of Earth, so if you weight 100 kg on Earth, you would weigh 240 kg on Jupiter. Saturn. Saturn's surface gravity is 10.44 meter per second square. The surface gravity on Saturn is about 107% of the surface gravity on Earth. So, if you weigh 100 pounds on Earth, you would weigh 107 pounds on Saturn. Uranus. Gravity on Uranus is 8.69 meter per second square. Gravity on Uranus is only about 90% that of Earth. If you weighed 100 pounds on Earth, you would weigh 91 pounds on Uranus. Neptune. It is 3.86 times the size of Earth and 17 times as massive. All of this work out to a surface gravity of 11.15 meter per second square, which again is measured at Neptune cloud tops. If you weigh 100 kg on Earth, you would weigh 114 kg on Neptune.